Okay, here we go now with question 8 on page 296. In the triangle PQR, PQ is 16, QR is 19, and the angle at R is 42 degrees. Okay. Find the possible values. This time it's find the possible values, but there was only one. Find the possible values at P correct to the nearest degree. Okay, so let's find these. Let's go the sine of P over 19 is equal to the sine of 42 degrees over 60. Okay, so let's evaluate. I'll do two things at one time now. Angle P equals the inverse sine of 19 times the sine of 42 degrees all over 16. Okay, we get 52 degrees. 52.6. Well, they said to the nearest degree, which is 53 degrees. Now, hopefully being flippant there won't matter. Now, the point is 53 and 42 is less than 180, and that means, oh, I hope I haven't removed that, I haven't. So that means we can roll forward and take the supplement, which is for the obtuse case. Okay, so this angle could be much wider as well. So we look at the obtuse case and we get 127 degrees or 127 degrees, and they're both valid. We accept them both. Okay, so with question 27 there was only one possible answer. With question 8 there are two possible answers. Okay, we'll probably get the rest of them done here now. We'll go on to question 9. So I'll read it. You have it in front of you in your book. Possibly don't. Let's see here. So question 9. In a triangle PQR, let's cross out 8, we finished 8. In a triangle PQR, triangle PQR, the angle at Q is 30. The length QR equals 15. And the length RP is 5√3. Find two values. So they tell us there's two values for the angle at P. Great, let's go get them. Okay, so let's see if we can speed things along here. Let's go P equals inverse sine of the thing opposite P times the sine of the other angle that we know divided by the opposite to that other angle. Okay, so let's plug that in the calculator, and then let's just call P prime 180 degrees minus this. Okay, no need to write it all out. The examiner knows what you're talking about there. That's the same as that. Okay, P prime, just, or we can go acute and obtuse. Okay, I already have a 180 minus sign. Oh no, you won't in reality, so let's start this from the top. So shift sine fraction bar 15 is the scalar, the multiplier. Sine of 30, of course we can drop downstairs straight away with that sine 30 because that's a half, so we can make this 10 root 3. 10 root 3. Okay. That's 60 degrees or 120 degrees. And what's interesting about that would have been 3. A little bit surprised. Oh yeah, because the sine of 60 is root 3 over 2. And that's how it worked out with all those numbers. So you could have done that without a calculator. On that point, let's just say now, in many exams around the world, you might have a situation where you're not allowed to use a calculator, and we should have spotted that there. Of course, in this country you can, but that's actually a disadvantage. So let's do it without using the calculator. So once I got to inverse sine, if I was thinking as analytically as I could, I'm thinking, can I do this analytically, meaning without technology, without approximating it? We should really only be using our calculator when we need to approximate real numbers. That would have turned into a 3. That would have turned into a 2 downstairs. And 3 over root 3 would have turned into a root 3 upstairs. So we would have been talking like this. And of course the angle whose sine is root 3 over 2 is 60 degrees, and then that would have turned into 120 degrees. So apologies for not spotting that from day one, but just be aware that there is that thing out there where the solutions are algebraic. Okay, we're going on to question 10. So PQR is the triangle, and PQ is root 12. PR is root 8. And we're to find the angle at Q. No, the angle at Q is 45 degrees. And we're to find two possible angles here. So we're going to find R acute, and we're going to find R obtuse. So R acute will be an inverse sine. It'll definitely be proportional to its opposite number, root 12. Okay. So think that over that equals this, which is sine. And again, this looks like one I'll be doing on pen and paper, over root 8. So let's get rid of that now for a minute. Sine of 45 is 1 over root 2. And then you have a 2 below, and 2 on 8 is root 16. Root of 16 is 4. So that's all that gone. Now, this is 2 root 3, because there's a 4 in there. And this is 2. So the angle whose sine is root 3 over 2 is again 60 degrees. And again 120 degrees is the alternative. That's the acute version, and this is the obtuse version. Sorry about that, I went off page there for a minute. So that was all done analytically. So it was done without a calculator, no calculator, and it was done because we recognized the sine and cos and tan, if you like, sometimes of those special angles. And while they're special because they have algebraic trig values. Okay, moving on now to question 10. Triangle again is PQR. God, I couldn't make up anything else. PQR. The angle is PQR. We have a root 12 here. We have a root 8 here. And we have 45 degrees here. This is not the one I just did? Oh, sorry. I'm not going to delete the whole video for just that. Silly me. Okay, 2 to go. 11. In the triangle MNP, MP is 8 centimeters. NP is 15 centimeters. By the way, when they're both in centimeters like that, you're going to be working with angles and they're not going to matter. You're not going to have to focus on this. And the angle at M is 62 degrees. Show that there is only one possible value for the angle at N. Okay, time to work again on our conjecture. Well, I'm not even sure what our conjecture is anymore, because let me see what we wrote. The angle opposite the shortest side. Our conjecture was that the smallest angle has a supplementary option when solving. That the smallest angle has a supplementary. I'm not too sure about that, so let's see. So let's get it anyway. So we'll basically go that angle N is equal to the angle whose sine is equal to. So what we definitely want to see opposite the N, the angle N, is 8. N over 8, and we want to see sine of 62 over 15, and we certainly wanted to see that. We knew 8 was on top. Okay, so well, the 62 degrees is never going to give us any, this is going to mess things up, so there's no bringing rationality back into it, so we're definitely using a calculator in other words. So shift sine 8 sine 62, close your bracket down to 15, and close your bracket there. That's equal to 28.1 degrees, we'll call it. Store it to A just in case we want it exactly. Okay. Oh, so it's okay, and 180 minus that alpha I saved. I didn't have to do that, but I did. Would give me 151 as the other candidate. 152 degrees is the obtuse candidate, but you can see here that's absolutely no way possible, because that goes too big. Okay, so we reject that. So it's just 62 and 28.1 degrees. So what I'd like to do is ask the question, if that's true, then we have 180 minus 62. Yeah, I store that to A, which is great, so I can subtract recall A to get the exact value for this angle here is 89.9, and I'll store that value to B. Okay, so let's get this length, because I'm trying to figure out what's the cutoff. When can you have? How can you tell if there's an option for obtuse? I'm interested, and rather than look at the computer, which will tell me straight away some theorem, I'd like to try and figure it out for myself. So we'll just say that the answer here, I'm applying the sine rule now, equals fraction bar be proportional to 8 over this. So I'll say 8 over sine 28.1, and I need to go back upstairs and put a sine in. What am I doing? The sine of this. The sine of 89.9. So this is around 17. these are the two long sides. So maybe it is that the two long sides can never provide. That's the mediumest and the longest side. The thing in between those two can never swing over and become. So he can probably swing over because he's between the longest and the shortest. And maybe he can too. Okay. But this one can't. Okay, I think that's great. I'm going to cut it off there, the battery's nearly gone.